So first we're going to learn how to name alkanes. You take the prefixes here and add the ane ending. So one carbon is just methane, 2 is ethane, 3 is propane, 4 carbons is butane, 5 is pentane, 6 is hexane, and 7 is heptane.
And now we're moving on to alkenes, which are just hydrocarbons with a double bond. And the way you count those is you just do the largest carbon chain that includes that double bond and add an ene ending. So as you can see, we're going to go through them here. That's 1 heptene, 2 heptene, that's 3 heptene, and it's not actually going to be 4 heptene because we have to do a number switch, because you always want to do the lowest number possible when naming a carbon chain. So it's actually 3 heptene again, and then we continue on down to 2 heptene and then 1 heptene once again.
To name side chains, identify the group coming off the longest carbon chain and number accordingly. So to start, we have 2-methylheptane, and then 3-methylheptane. And then we switch the numbers to make sure that it's the lowest number possible, so it's 4-methylheptane. And then here we are adding an ethyl group to the heptane, but we do not call it 2-ethylheptane because at this point the heptane is not the longest carbon chain. So if you count the longest carbon chain, it actually has 8 carbons. So we will name it 3-methyloctane.
And here we have haloalkanes, and the 4 main halogen groups that you're going to encounter are chlorine, which is chloro, fluorine, fluoro, bromine, bromo, and iodine, iodo for their prefixes. So here we're going to have an example of 1-chloropentane, and then add another group and it becomes 1,3-dichloropentane. Move it over 1, it's 2,3-chloropentane. Now here, you think it might be 3-4, but remember we have to do the number switch because you always want to go with the lowest number. So it's actually 2,3-dichloro. And here we have another dichloro on the same one, just do 2,2 when you're naming it.
So here we're going to name alcohols, which is the same idea except with the OL ending. So that's 1-heptanol, this is 2-heptanol, 3-heptanol, 4-heptanol, I think it's 5-heptanol, but it's not because you have to make sure that you're using the lowest number. So that's 3-heptanol again, then 2-heptanol, and 1-heptanol.
To name ethers, you're just going to name the 2 different groups separated by the oxygen and then add ether at the end. So here we have 2 carbons, so that's just going to be dimethyl ether. Add another carbon on one end, it's going to be methyl ethyl ether. Add one on the other side, it's diethyl ether. And then take one away and add another one, it's just methyl propyl ether.
To name ketones, you add the ONE ending along with the number where the double bonded oxygen is. So this here is it's the double bonded oxygen is on the 2nd carbon, so it's 2-hexanone. This is 3-hexanone. And this is again 3-hexanone, not 4, and then this is 2-hexanone.
Aldehydes are just large carbon chains that have a double bonded oxygen on the end. So pretty simple to name, all you do is add an ale ending to the largest carbon chain. So here's hexanal. And then even if you do have like a methyl or an ethyl group on the end, it doesn't matter, you still have to name it appropriately, starting with the aldehyde group because it takes precedence over it.
To name esters, you first name the alkyl group, not double bonded to the oxygen, and then the other group plus the OATE ending. So this is methyl methanoate. This is methyl ethanoate. Another one, and it's ethyl ethanoate. One more, and it's ethyl propanoate.
Next up we have carboxylic acids, which are really simple because they just have a double bonded oxygen on one group and then an OH group on the others, and they're always going to be next to each other. So here we have pentanoic acid because we just named the largest carbon chain and add an oic acid at the ending. Add 1, we have hexanoic acid, and add a chlorine, you have to name where it's at on the carbon, so 3, and then here we move to 5, and then just hexanoic acid.
To name amides, you name the alkyl group double bonded to the oxygen and add the amide ending, and then you name the other branching groups. So here, this is methylethanamide. This is ethylethanamide. We add another group, ethylmethylamide, and then diethylethanamide.
Here we have amines, and those are just nitrogen groups with branching carbon chains and then sometimes branching hydrogens. And the way you're going to name these is just name the largest carbon chain, and then if you have any branching groups, like a methyl or ethyl group, you'll just name them ethyl or methyl, and then add your amine ending on your main group. So starting just with one carbon, you'll have methanamine, 2 carbons is ethanamine, and then if you take away one hydrogen and add on a methyl group, it turns into methylethanamine. Take away the other one, you get dimethylethanamine. Add one more carbon on to one of the methyl chains, and you're going to get ethylmethylethanamine. And then add another carbon on, you'll get diethylethanamine. And then adding on another carbon to the longest chain would change it to diethylpropanamine, because now you have 3 on the main chain, and then you'll have your 2 branching diethyl groups coming off of the nitrogen group. Here we just have some miscellaneous information that you guys will need for organic chemistry this year. So this is isopropyl chloride, which you can see is just regular propyl group, but the chlorine's bonded at the middle carbon, thus making it into like a C-shaped. Isobutyl chloride is really similar to isopropyl chloride, except for you have that one extra carbon that's attached to the halogen group. And tert butyl chloride makes a branching 3 carbons coming off of the one middle carbon. Then we have sec butyl chloride, which looks like it could just be named 2-butyl chloride, but it's just given the name sec butyl chloride. And that's all the simple compounds we can name, but don't forget there's more complex ones that you'll learn later throughout the year. Thanks for watching.